Hi, so we just need to do a little bit of work on the converting of these fractions into indices before we differentiate, because I think that is the bit that is quite tricky at the moment. So if you think about the first one, I think you'll already know the first one, but if you're talking about the first one there, 1 over x cubed is going to be x to the negative 3, okay? So we've got to make sure we convert it to indices before we differentiate. Now the second one, the 2 is a whole number there, so effectively you've got 2 multiplied by 1 over x. So the 2 stays where it is, and then 1 over x would be x to the minus 1. Okay. And now this last one is the one that is the trickiest. And what I'd recommend you do is similar to as I said with this one, what I said with this one when I talked over it was to view it as 2 times 1 over x. Okay. And then you can say that that's 2x to the minus 1. So I want you to view the bottom one in the same way. So effectively what you've got there is you've got 4/5 multiplied by 1 over x squared. And so you're separating those just because you can't take the whole 5x squared and do a negative 1 with it, or take a 5x and do negative 2 with it, because then you'd be affecting the 5. So actually what you've got to do is separate that into 2 fractions there. So 4/5 times 1 over x squared, which means then you can go 4/5 x to the minus 2, and that is going to be what it is as indices. Now from there we can differentiate them all. So if you wanted to differentiate that, you'd get negative 3 x to the minus 4. If you wanted to differentiate that, you'd get negative 2 x to the minus 2. If you wanted to differentiate this, you get negative 8 over 5 x to the minus 3, okay? So that would be the differentiation at the end, but initially, you've just got to make sure, especially with that bottom one, that you separate it into 2 fractions, change the 1 over x squared into x to the minus 2, and then differentiate from there. Okay, I hope that helps. Give me a shout with your answers.